Alright, welcome. In this video, I'm going to be working Algebra 2 Quiz 7.3. Now, in this lesson, pretty much all you learned that you have to know for the quizzes and the tests is that if you've got a polynomial with real coefficients and a plus bi is a root of that polynomial, then a minus bi has to also be a root of that polynomial. So, since there's really only one thing, we decided to kind of spice this quiz up with some topics, from a little farther back, maybe that we didn't hit on the quiz that we need you to know for the test. And, so it wasn't the same thing over and over again. So you'll see like a bunch of different stuff here. So first thing, write the complex number square root of 50 in terms of I, simplify your answer. So it's kind of like simplify the radicals. So 50, thinking about a square number that divides 50, that would be 25. So 50 is 25 times 2. So I'm going to write that as the square root of 25 times 2 times negative 1. And then I can split that up into the product of these square roots. Okay, and the square root of 25 is 5. Square root of 2, I don't really have anything to do with that, but square root of negative 1, we're calling that I. Okay, so that's how I would simplify that. All right, the value of I to the 82 and I to the 73, these higher powers of I. What I'm recommending you do for these is divide them in half if they're even. So half of 82 would be 41. I squared is negative 1. Negative 1 to an odd power is negative 1. Okay? And if we've got an odd power of I, like I to the 73, just, kind of break off one of them. So that's going to be I times I to the 72. And then I to the 72, that's an even number. We're going to do the same thing. So I times, okay, what do I do how do I divide 72 in half? That would be 36. And I squared is negative 1 to the 36th power. Okay, negative 1 to the 36th power, it's an even number. An even number of negative 1s would make positive 1, so that's positive I. Okay, and those are the values of I to the 82 and I to the 73. If p of x is a fourth degree polynomial with rational coefficients, and that does mean real coefficients, because the rationals are a subset of the reals. P of x is equal to 0 when x is 1 plus square root of 2 and x equals 3i. Write a factored form equation for p. Well, we know that if x is 1 plus square root of 2 is a 0 of a polynomial with rational coefficients, 1 minus the square root of 2 has to also be a root. We learned that in the last unit, and what we just learned this time is if x equals 3i is a root, then x equals negative 3i is also going to be a root because the polynomial has rational coefficients that are real numbers. So, factored form equation for p didn't say anything about the leading coefficient, so p of x is going to be x minus 1 plus the square root of 2 times x minus 1 minus the square root of 2 times x minus 3i times x minus negative 3i. And that would be a factored form equation. We don't need to multiply that out. If q is a fourth degree polynomial with a negative leading coefficient and two complex roots, a graph that could possibly represent q would look like this. You could do without the wiggles, right? It could just look like a downward facing parabola. But it's going to have that in behavior because of the degree and leading coefficient. And the fact that it has two complex roots means that we could also have one double root, right? It could look like that. Okay, that would also be a potential graph, but I think most of the students in my class gave me something that looked like this, and that was perfectly fine. All right, all solutions to the equation. We're going to solve this one by factoring. Yeah, I see four terms. 1 to 4 is the same, or 1 to negative 4 is the same ratio as 2 to negative 8. I'm seeing a greatest common factor, though, so I'm going to start with that. But actually, say square bracket there. X to the third minus 4x squared plus 2x minus 8, and that's going to equal 0. And then I'm going to factor from the first two terms an x squared, and from the second two terms a positive 2. And then I'm going to factor out that x minus 4, and I'm left with an x squared plus 2. Okay, so now that I've got it factored, either x could equal 0, that would give me x equals 0, x minus 4 could equal 0, and that would be where x was equal to 4, or x squared plus 2 could equal 0. I'm going to solve for that one kind of more directly. so the square root of negative 2 is going to be the square root of 2 times the square root of negative 1. And so I'll have x equals root 2 times I, and x equals negative root 2 times I. All right, write the expression in standard form. Okay, so we're going to need to multiply this one out. 1/2 plus 1/4 of I times 1/2 plus 1/4 of I. Okay, we're going to multiply this out. 1/2 times 1/2 plus 1/2 times 1/4 of I, that would be 1/8 of I. 1/4 of I times 1/2, that would be another 1/8 of I. And then the last two would be 1/4 times 1/4 is 1/16 of I squared. Okay. I squared is negative 1, so that would be minus 1 over 16th. And 1/4 minus 1/16th, I know I'm going to have to put those together. I might as well call 1/4 4 over 16 to make this a little easier to look at. So I'm going to combine the like terms. 4 minus 1 would be 3/16, 1/8, and another 1/8 would be 2/8 or 1/4 of I. Write a standard form polynomial with rational coefficients that has zeros at x equals 0, x equals 3, and x equals 1 plus 4i. Well, if I know that x equals 1 plus 4i is a root and the polynomial has rational coefficients, then x, hold on, it's not back in that spot. X equals 1 minus 4i is also going to be a root. And pardon me, I'm trying to squeeze that in. Okay. So the factors, it didn't say anything about the leading coefficients, so I'm just going to say x minus 0 times x minus negative 3 times x minus 1 plus 4i times x minus 1 minus 4i. And then I'm just going to multiply this all out. Okay, the x times the x plus 3, that would be x squared plus 3x. And then the other ones will be, okay, I'm going to need to do that off to the side, but maybe I'll say x minus 1 plus 4i times x minus 1 plus 4i, where I just distribute the negatives. Then I'm going to go off to the side and do that multiplication, maybe with a box. Hopefully at this point you've done this quite a few times. And you know how this is going to play out. All the things with an imaginary number attached to them are going to either, cancel each other off or be I squared, which is actually real numbers. Negative x, negative ix, positive 1, positive 4i, negative 4i, positive 4ix. Yeah, this is all canceling. And then negative 16i squared. So when I put this all together, I have x squared minus 2x plus 1, plus 1 minus 16 times negative 1, so that would be plus 16, so that's a total of 17. Okay, now I'm going to set up for a little bit more multiplication. Probably have to erase that out of here. Let's say, all right, x squared, negative 2x, and positive 17. Multiplied by x squared and positive 3x. All right, that would be 30, and 21 is 51x. All right. Yeah. So I've got x to the 4. On x to the thirds, I've got 3 minus 2 is 1, x to the third. For x squareds, I've got 17 minus 6 would be 11x squareds, and then 51x's. All right, there we go. That's going to be our standard form polynomial with rational coefficients. All right, now form B. Let's write the complex number square root of negative 300 in terms of I. So we're going to kind of say, okay, what divides 300 that's a square number? And that would be 100, because that's 10 times 10. So that's 100 times 3 times negative 1. So that's the square root of 100 times the square root of 3 times the square root of -1, which is 10 square root of 3i. I to the 83 and I to the 72. Okay, with these, I'm recommending that you try to divide them in half, and if you can't, divide them in half directly, then, get them to a point where you can. So with I to the 83, break off one of them, and then you'll have an even number. So I times, and then we can divide this in half. So 82 is 2 times 41. And what was I thinking about this? Oh yeah, so I times -1 to the 41st power, and 41 is is an odd number, so -1 to an odd power is going to be -1, and -1 times I, that's -I. Then I to the 72, to divide that in half, and half of 72 is 36. And that's -1 to the 36th power, and an even power of -1 is going to be +1. So that's how we're taking those high powers of I. If p of x is a 4-3 polynomial with rational coefficients, and p is equal to 0 when x equals 3 plus 2i and x equals √6, then we also know that x equals 3 minus 2i and x equals the negative square root of 6, not 2, are also going to be roots of p of x. So my factored form equation would be, okay, nothing about a leading coefficient. It's going to be x minus 3 plus 2i times x minus 3 minus 2i times x minus the square root of 6 times x minus the negative square root of 6. And that's my factored form equation. We're asking for a sketch of a fifth-degree polynomial with a negative leading coefficient and 2 complex roots. So that means it's got 3 real roots. Okay, so the most common response I got was, okay, fifth-degree polynomial with a negative leading coefficient and 3 real roots. There they are. It can have, 2 more terms if you want. But you don't have to. Okay, that was the most common. Now, a person could also say, okay, well, maybe one of them was a double root, something like that. That's an option. You could also have a triple root, and then one more turnaround. Okay, these are all options that some people gave, but I think the most common answer is the one that I've got here big on screen. Okay, this next one, find all solutions to the equation, where, you get asked to solve a polynomial equation in this class, so you're going to have to set it equal to 0, unless it's only got one term with an x in it, then we can solve it directly. And if we set it equal to 0, pretty much we're either factoring or we're using like quadratic formula, rational root theorem, something like that, which is way worse. So you should see an equation and hope to be able to factor it. And then if we see 4 terms and we see kind of this parallel ratio, 1 to -2 is the same as 3 to -6, we know we're going to be able to do group and factor. But we should always start by looking for a greatest common factor. And I see x in all 4 of these terms, so I'm going to factor that out first. And then I'm going to do group and factor on the thing that's in the square brackets. And then I can factor out the x minus 2. I'll be left with an x squared plus 3. Now that I've got my factors, I can find my zeros. Okay, because if any of the factors was 0, then I know that the whole product would be 0. That's the zero product property. So if x was equal to 0, the whole product would equal 0. If x was equal to 2, then the middle term would be 0, and the whole product would be 0. And the x squared plus 3, okay, that's maybe not one we've solved quite yet, but maybe it is. I'm going to solve that one directly because, like I said earlier, it's only got one thing with x in it. So I'm going to take the square root of both sides, and that's going to be plus or minus the square root of 3 times the square root of -1. And so I'll have x equals plus or minus √3 times I. Those will be my 4 solutions to that equation. This next one is write the expression in standard form a plus bi. Alright, we can do that. We're going to actually multiply it out. We can't just square both of the things. That would be nice. But it wouldn't be right. It would lead to other problems. So we're going to set up for the long multiplication. 1/4 times 1/4 is 1/16. 1/4 times half of I, that would be 1/8 of I. Half of I times 1/4, that's also going to be 1/8 of I, and 1/2 I times 1/2 I is positive 1/4 of I squared. Okay, so that'll be 1/16. I squared is -1, so minus 1/4, plus 1/8 of I, plus another 1/8 of I. Okay, now if I'm going to combine the 16th and the 4th, I need to have a common denominator, so I might as well write that 4th as 4/16. So if I have 1 minus 4, that would be -3/16, and 2/8, that is 1/4 of I. And that's standard form a plus bi. Right, and the last problem is write a standard form polynomial with rational coefficients that has zeros at x equals 0, x equals -2, and x equals 1 plus 3i. Okay, well, we know that if we're going to want to have rational coefficients, then we're going to need to include x equals 1 minus 3i as well. Okay, so I'll have x minus 0 times x minus -2 times x minus 1 plus 3i times x minus 1 minus 3i. Those would be my 4 factors. And, if it said the leading coefficient was 10, I'd put a 10 out in the front, but it didn't say anything about it, so I'm just going to assume the leading coefficient is 1. And I'm going to distribute the x over the x plus 2. And I'm going to distribute the negatives in these things, so x minus 1 minus 3i and x minus 1 plus 3i. I'm going to set up for some long multiplication for the things with the i's in them. So x minus 1 minus 3i multiplied by x minus 1 and plus 3i. Oh no. Alright, there, I think that's better. So I've got x squared plus 2x times, alright, combining like terms, I've got x squared negative 2x. Okay, notice the negative 3ix and the plus 3ix and cancel off. And same with the plus 3i minus 3i. And so I've got plus 1 plus 9, because negative 9i squared is negative 9 times negative 1, so that would be plus 10. And now I set up for a little bit more multiplication. X squared minus 2x plus 10 multiplied by x squared and positive 2x. Alright, let me just double check. I feel like I didn't do that entirely right. Okay, must be good. Yeah, okay, that's fine. Better to check a second time. So I've got x to the 4. On x to the 3's, I've got negative 2 plus 2, so that's none of them. For x squareds, I've got 10 minus 4 is 6. And then 20x. And yep, that's going to be all the problems for this quiz, so thanks for watching.